Hello everyone, hope you are doing well. So today we are going to talk about some typical concentration terms. Under this, we are going to discuss about the second typical concentration term, which is percentage labeling of oleum. So first we'll discuss what's oleum actually. So oleum is basically a mixture of H2SO4, which is sulfuric acid, and SO3. So it's a mixture of sulfuric acid and SO3. Here H2SO4 is the acid and SO3 is anhydride of acid. Anhydride is basically the substance which we obtain after removing water from original compound. So when we add water to SO3, we'll get the acid, which is H2SO4. So on adding water to anhydride, we'll get the original compound, which was H2SO4 in this case. Now we'll discuss about the definition of percentage labeling of oleum. So we'll write percent labeling of oleum is defined percent labeling of oleum is defined as the weight in gram of H2SO4, basically sulfuric acid, obtained by the complete hydrolysis of by the complete hydrolysis of 100 gram of oleum sample. 100 gram oleum sample. So this is the definition. So percent labeling of oleum is defined as weight in gram of H2SO4 obtained by the complete hydrolysis of 100 gram oleum sample. So just remember the definition. Now we'll write an example so you better understand. So let's say oleum is given as 109% in a compound. We have oleum as 109%. So we know what's oleum. It is H2SO4 plus SO3. The weight of H2SO4 in this case will be 60 gram and SO3 is 40 gram. This is standard weight for 100 gram oleum sample. Now for final mixture we have to do complete hydrolysis, basically adding water, and we'll get oleum as 109 percentage, which in simple term also means that the weight of H2SO4 finally obtained will be 109 gram. This is simple conclusion which we can draw from the above given example, that 109% oleum means 109 gram H2SO4 in the final sample. So molecular weight of SO3 we know it is 80 gram per mole and weight of water is 109 minus 100, which will come out to be 9 gram. So weight of water added is 9 gram. Molecular weight of SO3 is 80 gram per mole. So on adding water to SO3 we got H2SO4, right? At t is equal to 0 times 0 we'll write number of moles of SO3 first. So moles will be weight divided by molecular weight. It will come out to be 40 divided by 80. So 1 by 2. Similarly for water, it will be 1 by 2 moles at time t equal to t. When the reaction will be over, then these both of them have the same stoichiometric coefficient, so both will get completely utilized. So moles of H2SO4 which will be obtained finally will be 1 by 2 moles. So we can write weight of H2SO4 finally as weight of H2SO formed as moles multiplied by molecular weight of H2SO4, which is 98 gram per mole. So 1 by 2 multiplied by 98, it will come out to be 49 gram. So weight of H2SO4 formed will be 49 gram, right? So this is simple example. Just to give you a quick overview of oleum, now we'll talk about percent free SO3. This is also an important topic which comes under percentage labeling of oleum. So first we'll write the definition of percentage free SO3. So it's the weight in gram of it's the weight in gram of SO3 present in 100 gram of oleum sample. So this is the simple definition, that percent free SO3 is the weight in gram of SO3 present in 100 gram of oleum sample. So simply remember this definition. Now we'll write the formula for percent free SO3. Just remember this simple formula so we'll be able to solve the problems. We'll write percent free SO3 is equal to percentage labeling of oleum minus 100 divided by 18 multiplied by 80. So this is simple formula. Just remember it. Percentage free SO3 is equal to percentage labeling of oleum minus 100 divided by 18 multiplied by 80. Now moving further, we'll solve a problem. Here a 30 gram oleum sample contains 6 gram of S2SO4. Find percentage labeling of this oleum sample. So we have to find percentage labeling. So first we'll write what's oleum. It is a mixture of S2SO4 and SO3, right? Here we are given the weight of oleum sample is 30 gram. The weight of S2SO4 is 6 gram as per the problem, and weight of SO3 we don't know, right? So how will we find it out? So we'll write weight of SO3 is equal to weight of oleum minus weight of S2SO4. So simply 30 gram minus 6 gram, it will come out to be 24 grams. So weight of SO3 is 24 gram. Also we can write percentage free SO3. So as per the definition, we'll write weight in gram of SO3 present in 100 gram oleum sample, right? So 24 divided by 30 multiplied by 100, it will come out to be 80. So this is percentage free SO3. We have to find out percentage labeling. So we'll write the formula that percentage free SO3 is basically percentage labeling or percentage labeling of oleum minus 100 divided by 18 multiplied by 80. So we'll simply put these values. So percentage free SO3, it is itself 80 is equal to percentage labeling, which we have to find out, minus 100 divided by 18 multiplied by 80. So 80 and 80 will get cancelled out. So percentage labeling of oleum will come out to be 100 plus 18, right? So it is 118%. So simply this is the answer for this problem. Now we'll move further. We'll write a note. This is an important note. Under this we'll write percent labeling of oleum can also be expressed as percent labeling of oleum can also be expressed as 100 plus X percent. If somewhere you are given percentage labeling of oleum is equal to 100 plus some X percentage, then here X refers to the weight in gram of H2O added or weight in gram of water added to completely hydrate 100 gram of oleum sample. Completely hydrate 100 gram of oleum sample. So X is basically weight in gram of water added to completely hydrate 100 gram oleum sample. So if such expression is given, just remember what do we mean by X, the simple term, right? Now we'll move further. We'll write minimum labeling of oleum. So what can be the minimum value of percent labeling of oleum? We'll discuss about it here. That for minimum labeling we will have weight of SO3 in oleum is equal to 0 gram. We know oleum consists of S2SO4 and SO3, right? So for minimum labeling of oleum, the weight of SO3 should be 0 gram. In a 100 gram sample of oleum, weight of S2SO4 will be 100 gram and weight of SO3 should be 0 gram for minimum labeling, right? So we'll write percent free SO3 in this case will be simply 0 divided by 100 multiplied by 100, which is itself 0, right? So percentage free SO3 is 0. We'll write percentage labeling. So for that purpose, we'll first write the formula. Percentage free SO3 is equal to percentage labeling minus 100 divided by 18 multiplied by 80, right? So we'll simply put the value percent is free SO3, in this case is 0, is equal to percentage labeling minus 100 divided by 18 multiplied by 80. So on further solving, percentage labeling will simply come out to be 100. So this is the minimum labeling of an oleum sample. Just remember this simple value. This is minimum. Now we'll talk about maximum. So we'll write maximum labeling of oleum. So what can be the maximum value of percentage labeling of oleum? We'll discuss here that for maximum labeling, the weight of SO3 in oleum should be equal to 100 gram. So in this case it's just the opposite as it was in the earlier case. So oleum, we know it consists of S2SO4 and SO3 mixture. Here it's 100 gram. The weight of SO3 is 100 gram. So weight of S2SO4 will simply be 0 gram. Now we'll write the percent free SO3 in this case, which is 100 divided by 100 multiplied by 100. It will simply come out to be 100. We got the percentage free SO3. Using this, we'll write percentage labeling of oleum in this case. So we'll first write the formula that percentage free SO3 is equal to percentage labeling minus 100 divided by 18 multiplied by 80. So simply putting the value 100 is equal to percentage labeling minus 100 divided by 18 multiplied by 80. On solving, we'll get percentage labeling is equal to 122.5 percentage. So this is the maximum value. This is maximum value of percentage labeling of oleum. So we finally got that the range of the range for percent labeling of oleum is 100 to 122.5, right? 100 is the minimum, 122.5 is the maximum. 100 to 122.5. This may be asked in the problem in basically single correct problem directly. That's why we discussed. Now we'll solve a problem here. 6 gram of S2O is added to 100 gram of an oleum sample labeled as 109%. In final mixture, find of weight of S2SO4 formed, weight of SO3 left, and percentage labeling of oleum in newly formed sample. So we know oleum is S2SO4 is a mixture of S2SO4 and SO3, right? So here it's 100 gram, and a standard 100 gram oleum mixture, the weight of S2SO4 is 60 gram and SO3 is considered 40 grams. So 6 gram of water is added as per the problem, and finally we know that S2, when water is added to SO3, it forms S2SO4, right? So we'll write the moles of SO3, which is weight divided by molecular weight, 40 divided by 80 gram per mole, it will come out to be 1 by 2. Similarly, moles of water, it will come out to be 6 divided by 18, which is 1 by 3, right? So at time t equal to 0, we have moles of SO3 as 1 by 2 and moles of water as 1 by 3, right? Now we'll calculate the moles to stoichiometric coefficient ratio. So on calculating, we'll get that moles to stoichiometric coefficient ratio of water is lower, so water is the LR here, so water will be consumed completely, whereas SO3 will be left. How much SO3 will be left? It will be 1 by 2 minus 1 by 3, which is 1 by 6 moles. Similarly, S2SO4 will be formed. How much S2SO4 will be formed? It will be determined by LR. So water is LR, so 1 by 3 moles will be formed. Now we have to find out weight of S2SO4 formed in the first part, right? So weight of S2SO4 formed will be moles multiplied by molecular weight. That will be the weight of S2SO4 formed. So it will come out to be 98 by 3 gram. This is the answer for first part. In second part, we have to find out weight of SO3 left. So it will be moles multiplied by molecular weight. How many moles of SO3 is left? It is 1 by 6 multiplied by 80 gram per mole. It will come out to be 40 by 3 grams. Now in third part, we have to find out percentage labeling of oleum in newly formed sample, right? This is the answer of first part, this is the answer of second part, and in third part we have to find out percentage labeling of oleum in new sample, right? This is the problem. So we know S2SO4 and SO3, these two are the mixture for oleum, and how much S2SO4 is present? So 60 gram plus this S2SO4 formed, which is 98 by 3 grams, so it is 60 plus 98 by 3. And similarly we'll write for SO3, how much SO3 is present here? It is 40 by 3 gram. If we sum it up, it will come out to be 60 plus 98 by 3 plus 40 by 3. It will be 106 gram. Sorry, 100, no, not 100, it is 106 gram. So to solve further, we'll move to next page. We have to find out percentage labeling of oleum in new sample or in the final sample, right? We have mixture of S2SO4 and SO3, right? How much S2SO4 is there? It is 60 plus 98 by 3 gram, 60 gram which we took earlier, and 98 by 3 gram which is formed later. And how much SO3 is there? It is 40 by 3 gram. This together weighs 106 gram, which is oleum here. And in this 106 gram we have 100 gram oleum and 6 gram of water, right? As per the problem, we have 100 gram oleum and 6 gram water in this 106 gram mixture. So 106 gram oleum has 40 by 3 gram of SO3, right? So 100 gram oleum will have, similarly, simply use unitary method, 40 by 3 multiplied by 100 divided by 106. This is the weight of SO3 in 100 gram oleum. Now we'll write percent free SO3, which will be simply the weight of SO3 here. Weight of SO3 present in 100 gram oleum sample is percent free SO3, right? It will come out to be 4000 divided by 308. Now we'll write the formula for percentage labeling, which is percentage free SO3 is equal to percentage labeling minus 100 divided by 18 multiplied by 80, right? Simply we'll put the value that percentage free SO3 here is 4000 divided by 318 is equal to percentage labeling, which we have to find out, percentage labeling of oleum minus 100 divided by 18 multiplied by 80. We'll simply solve it and we'll get the answer for percentage labeling. So percentage labeling is equal to 103. This will be the answer which will come out. It will be approximately 103. So percentage labeling of oleum in final sample or in new sample which is finally formed, right? Simply this is the answer. Hope you understand this. Now we'll talk about some other mixtures which behave as oleum. So there are some mixtures which behave as oleum. We know oleum, it is S2SO4 plus SO3, right? It is a mixture of S2SO4 and SO3. So there are some mixtures which behave similar as oleum. Here S2SO4 is the acid and SO3 is the anhydride of acid. Basically anhydride is formed when water is removed from the acid. So some other mixtures under this, we'll discuss the first mixture, which is S2SO4 plus CO2. Here S2SO4, S2CO3 plus CO2. Here S2CO3 is the acid and CO2 is the anhydride of acid. So the reaction will simply be, on adding water to CO2, it will form S2CO3, which is carbonic acid basically. So this is the first mixture. Similarly, the second mixture is, which behaves as oleum, is the mixture of S2SO3 and SO2. Here S2SO3 is the acid and SO2 is the anhydride. The reaction here simply will be, we'll add water to SO2 and it will form the acid, which is S2SO3. So SO2 plus H2O will give out S2SO3. Anhydride plus water is equal to the acid. The third mixture which behaves as oleum is HNO3 plus N2O5. Here HNO3 is the acid, N2O5 is the anhydride of acid. Simply we'll write the reaction here. Anhydride of HNO3 basically. Reaction here will be, we'll add water to N2O5. N2O5 plus H2O will give HNO3, right? If we simply balance it here, 2 will come, right? Now we'll write the fourth mixture which behaves as oleum. So it is H3PO4 plus P4O10. A mixture of H3PO4 and P4O10 behaves as oleum. Here H3PO4 is the acid and P4O10 is the anhydride of H3PO4. The reaction here simply will be P4O10 on reacting with water or on mixing water in it forms H3PO4. Now we'll simply balance it. So here it will be 4 and here adjacent to water we'll have stoichiometric coefficient as 6.